Hi, welcome to this video. Now in this video we are looking at part 4 of our trigonometry, question 4 of our trigonometry, part B, Roman numeral 3. So now here I want you to observe that it is 1 minus sine 2x and 1 plus sine 2x. So there is a 1 here which we can eliminate or replace with another identity. Now there is sine 2x we can also replace. So let us begin from there and we see how we move towards this other right hand side. So we know that 1 is equal to sine squared x plus cos squared, and now the sine 2x is the same as 2 sine x cos x. Now let us replace on the left hand side. So this is going to be sine squared x plus cos squared x, then minus sine 2x, we shall replace it with a 2 sine x cos x, then over down here this one is the same as sine squared x plus cos squared x, then there is a plus instead, so plus 2 sine x cos x. Well, so if you take a look at this, there is an identity, a binomial expansion, sorry. So remember a plus b squared is the same as a squared plus b squared plus 2ab, and a minus b squared is the same as a squared plus b squared minus 2ab. So there is an identity here. So there is this expansion here which you can replace with this. So when you look at this, a minus means we are going to use this one here. So you can use a cos minus a sine minus cos. Depends on the way how you are going to manipulate. So what I'm going to do here, I'm going to use a cos squared x, no, a cos x minus up here, cos x minus sine x squared. This is going to be cos squared plus sine squared, or sine squared plus cos squared, then minus 2 sine x cos x, then over. Now this is plus throughout, so we shall be using, let me use cos x plus sine x also squared. So now, so far what I have achieved is a square. You can see the square on the right hand side, but now inside there is a tan, no, there is a tan that is a 45, meaning there is a compound angle somewhere which we need to create, and definitely that should be above tan. We must find a way of manipulating this. Now when you say plus here, minus, a minus up and a plus down, and you want to get a tan, first of all let us first divide with a cos throughout in the numerator and in the denominator. So this will be cos x minus sine x over cos, then divided by cos x plus sine x also divided by a cos. I have not changed anything here, it is still squared. I have divided this, the numerator as a cos, and I have done the same, so the equation is not changed, it is still the same, only that I'm going to create a tan now, because sine over cos is tan, and I have a 1 here, so this is going to be 1 minus tan x, then down will be 1 plus and this thing is squared. So now from there we need to find a way how. Now look at what you are proving. There is a 45 here. Pi by 4 is the same as 45, and tan 45 is a 1. So remember that tan a minus b is the same as tan a minus tan b. If I'm to use this identity, then all over 1 plus tan a tan b. Now I'm going to compare this with this. Please, I'm comparing what is in the bracket only. Leave the square around at this point. Now tan a, here we have a 1. Then minus tan b, so b can be my x. Then I have a 1, and I have a plus. And here I just have only tan a, tan b, but here I have tan x only. So meaning that by mere looking at 45, you should get an idea if you have done much practice. It implies that I can be, since tan 45 or tan pi by 4 is equal to 1, it means that my a is 45 or pi by 4. So that's why we remain with a tan x here, and here we just have a 1. So we shall therefore come and we manipulate this as tan pi by 4 minus x, and all of it squared. So this is the same as this one here, if you have seen it. So on the right hand side, this is written this way. So I just bring the square here. I get tan squared, then pi by 4 minus x, which is our left hand side, and it is equivalent to the right hand side. So that's how we prove this number. Thank you for watching. Please subscribe to my channel, hit the notification bell. I am teacher Junjo Isaac. Let us meet in the next video of question 5, again trigonometry. Thank you.